In this video, we're going to look at the basics of a hypothesis test and some of the key components involved. So in a hypothesis test, there are two options. There's the null hypothesis and the alternative hypothesis. The null hypothesis is typically sort of the de facto or the default belief about what is true, and the alternative is typically the whole reason for the test, because the alternative is many times what a researcher suspects to be true. So we hope that we can conduct this test in such a way that we make the correct decision. So we have two options. One is to reject the null hypothesis, and the other is to fail to reject the null hypothesis. So the null hypothesis always gets an equal sign, as you see there. So we're assuming here that the unknown population parameter is mu, which is typically the population mean. And then the alternative typically takes one of three forms. It's either that the true population mean mu is different from mu naught, which is called a two-tailed test, or the true population mean mu is less than mu naught, which is called a left-tailed test. And then the third option is that the true population mean is bigger than mu naught, which is called a right-tailed test. So again, we have to make a decision. We have two options. And so based on the sample data present, we'll make that decision. There are four situations. You can see there in the second column here, that's the column that represents the situation where the null hypothesis really is the truth. And the second column represents the situation where the null hypothesis really is false. So the alternative really is true. Now, of course, these two things we don't know. I mean, one of them is true, but we just don't know which one. Our two options for the decision is either we fail to reject the null hypothesis or we reject the null hypothesis. And so there, you can see there from the table that there are two correct decisions, and then there are two times when we make an error. So the type 1 error, you notice, is the situation where we reject the null hypothesis even though it's true. And the probability of a type 1 error is alpha. That's called the significance level of the test. The probability of a type 2 error is typically called beta. So again, you see there that a type 1 error is the error we make where the null hypothesis really is true and we make a mistake. And the type 2 error is the other mistake. And again, the probability of making a type 1 error is called the significance level, and that is something that you do have control over whenever you set up the details of your test. So there's sort of a trade-off between the significance level and beta. So the smaller the significance level, then the larger will be the probability of a type 2 error. And we will say later on how to use the data to inform our decision.